to do every step that you do. And that's what a proof is. A proof is simply a logical sequence of explaining how do you get from what's been given to you to what your goal is to prove. So if I had an algebraic equation and I wanted to solve for x, solving for x is what I'm trying to prove. What is x? The equation is what I'm given, and then I'm going to go through and show every single step. You can't skip steps. You can't do things in your head. You have to show every step, and then you have to back up. What mathematical property, theorem, postulate, definition says I can do each of these steps? Okay? And the reason proofs become hard for students is because they don't know their definitions, their theorems, their postulates, or their properties. So they know how to work the problem, but they don't know how to back it up. And that's what we're going to practice on getting good at. The way to practice that, though, is to study your definitions, your theorems, your postulates, your properties. We'll start with algebra ones because they're easier and you're so good at algebra right now, and then we'll throw in all the new geometry. Okay? Only one vocabulary word today is proof, and here is a proof. Proof is an argument that uses logic, definitions, properties, previously proven statements, which are your theorems, to show that something is true. Okay, and I basically just said that. The most important part of writing a proof is giving a justification that shows every step can be done, that it shows it's valid. So we are going to be justifying everything we do today. All right, before we get to this, I'm going to make you set up your algebraic proofs different than what you probably did in Algebra 1 and different than what the book is going to ask you to do because of what we're going to do tomorrow. If we set our proofs up the same way we're going to do them tomorrow, it's going to make tomorrow easier. If we do our algebra proofs different than we do our geometry proofs, it's going to make it more difficult. So I'm going to have you set them up in this class. We are going to do 2-column proofs. We're going to talk on Tuesday about some other types of proofs, but our rule for the rest of the school year is no matter what the directions say, we're going to do 2-column proofs every time because we're going to master and get great at one kind of proof, and that's 2-column. And again, I'll talk to you about the other types on Tuesday. When I say 2-column proof, this is what you're going to do every time on your paper. You're going to draw what looks like a T-chart, 2-column. I'm going to be super picky. You have to label the left side statements. And you have to label the right side reasons. If you leave off those headings, I will count off points. So make sure you put statements and reasons. You're going to number every statement and every reason. So you're going to say, this is my first statement, this is my first reason. So you're going to number, and again, I'll count off if you don't number. And so what you're going to do is you're going to be given some information to start with. Most, not all the time, but most of the time, that means your very first reason is it was given. So you will put given. Okay? And then you're going to start doing the process of whatever it is you're trying to prove. Each step will then have a different reason that backs it up. Those reasons, again, come from definitions, theorems, postulates, or properties. And so you'll be writing things like definition of midpoint, or addition property of equality, or vertical angle theorem, whatever is backing up what you're trying to say here. So we start with algebra to make it easier. These are the algebraic properties that you should have learned sometime before you came here. If you didn't, then today you have to learn these, okay? Super important. I will not let you abbreviate. No abbreviations. Again, I'll be super picky about that. The only exception to that rule is you can use symbols. So anytime you see a word that we have a symbol for example, angle has a symbol, congruent has a symbol, equality has a symbol, you can use a symbol there and I will accept the symbol. So instead of having to write addition property of equality, you could put addition property of and then use equals. Okay? So all of these could just have the equal symbol here if you want to shortcut that and not run the risk of misspelling equality.
Thank you.
You okay? cannot abbreviate anything. So no, I understand that there's a little plus, minus, but those I'm not going to let you abbreviate, okay? Good question, though. All right, so addition property of equality, subtraction property, multiplication property, and division property. These four pretty much are the same type of reasoning. They are steps that we use to solve an algebraic equation. Basically, the addition property says if you have an equation and you choose to add something to both sides of the equation, you use the addition property. Be careful, this is not the addition property. If this is given to me and my next step is 5x equals 7, I did not use the addition property. The addition property says that you add something to both sides of the equation. I didn't add it to both sides. So this is doing what? Combining like terms. They don't have that listed here, so we're going to add it down at the bottom. And you can write one of two things. If you don't want to write combine like terms, which is 3 words, then you can do instead 1 word, simplify. And I'll accept it either way. So if you would rather write simplify, 1 word, that's fine. If you want to write combine like terms, that's fine. So you would have, if we had this kind of problem over here, 3x plus 2x equals 7 was given. Our next statement would be 5x equals 7, and our reason would be simplify. Okay, so you should have done something like this. They may not have been as picky about statements and reasons and lining it up under a T-table. Good. Usually in Algebra 1 they talk about it because they know you're headed to it in geometry. Right, and so I'm going to get more picky. And the reason I'm going to get more picky is because of the extra things we're going to be learning in here. We're going to have some of these properties of congruence and of equality, and so it's going to be important that you're putting that of equality because it's different if it's of congruence. So some of the things you might not have had to do there, there's a reason why we're doing it in geometry, and you'll learn as we go, okay? So these 4, kicker is you have to do it to both sides for it to be that property. If you're just multiplying 2 things on the same side of the equation, that is not multiplication property. That is simplify. Okay? If you're doing it to both sides, it's multiplication property. So for example, if I had something like this, what would I need to do here? Multiply both sides by 2. So that's the multiplication property. But if I have something like this, it's not actually simplify. We're going to talk about what it is. What is it? It's the distributive property, but it's not multiplication property, even though we're multiplying, because we're not doing it to both sides. Okay? So that is in your notes. If you'll flip ahead to the next slide there is the distributive property. Not always, but almost always. Okay, there's going to be a few situations we're going to look at today where the first step is not given, but given will be somewhere in your problem because there will be some information given to you. 95% of the time, your first step is given. Sometimes it's not. 95, I don't know. I'm just throwing out a statistic. Okay, distributive property. Again, I need you to add right here, though, this is of equality. So make sure you put the distributive property of equality. And I don't know why they didn't just put that on the other slide, but they didn't. This is another property that you can use, okay? Going back to that slide we were on, though, the first 4 have to be on both sides, okay? The next 3 are some of the most important geometry properties that you're going to use over and over and over this semester, okay? Reflexive property, symmetric property, and transitive property. Spelling, students always misspell symmetric. There are 2 M's. Be very careful, okay? It is reflex, like you're flexing, not reflect with a CT, okay? Reflex with an X, so be really careful. Yeah, reflexive. I know, it is, but you be careful that you're spelling it correctly. All right, so here's what it says. Reflexive property says something is equal to itself. So 5 equals 5, x equals x, 3 equals 3. If something is equal to itself, that's the reflexive property. And reflexive property is not used a lot in the algebraic proofs. Reflexive property is going to be used a lot more in the geometric proofs. So right now you may be saying, why would I ever want to write 5 equals 5 or x equals x? You'll see later when we get to the geometry proofs where we'll use that.
So, like, what if it was 3 equals 5?
That's not a true statement. You would never have that on your paper. Okay? So if something's equal to itself, you'll use reflexive. If you're saying x equals 3, that's going to be different, but you would never say 3 equals 5. Okay? Yes. All right. No. So again, we're not going to use reflexive much when it comes to, if any at all, algebraic proofs. I'll show you later where we'll use it. It'll be in our geometric proofs. Symmetric property of equality. Symmetric is where you flip your equation. If A equals B, then B equals A. You will use this often in your algebraic equations because I will make you write your answer as x equals a number, not a number equals x. So if you get something like 3 equals x as you go through and show your work, you automatically flip it in your mind, right? And say x equals 3, but you have to show that step in your proof. So that means that you use the symmetric property. But there's a reason, again, because we're building on this in our geometry. So you're going to take it, flip it over, that's your symmetric property. You have to. It is not finished until you're done, okay? Until it is x equals a number. You will miss points in your proof. Now, a proof is not completely right or completely wrong. You will get points for every step that you do. So a proof is going to be worth several points on a homework. And you'll get points for each step. But where you make mistakes, you're going to miss points. Okay? All right. Transitive property. Transitive property is like a train. You've got several cars that you're connecting together. It says if A equals B and B equals C, then A equals C. It looks very much like what we did yesterday. Which law looks like that? Syllogism, the law of syllogism. Okay, it's fine. The law of syllogism. The difference between the law of syllogism and the transitive property is the law of syllogism is if-then statements. This is not if-then statements. These are equations. Okay, so if you have something like, let's say 2x equals y, and y equals 3x plus 2. Then you're saying that 2x is the same as y, so this is like A equals B, and this is the same thing, so B equals C. So you can combine that and say 2x equals, exactly. And what you used was the transitive property of equality. Okay? So it looks just like the law of syllogism. You have something in common that you're getting rid of, and you're combining the other two parts. It also looks like substitution. And it is the most confused one. Transitive property looks like substitution, but it is not substitution. So here's how you can tell the difference. If you have two equations and one whole side of your equation is identical to the other whole side of your equation, then you're using the transitive property. You're getting rid of those sides and combining the other two. Okay, just like P implies Q, Q implied R, P implies R. Okay? Substitution, we're going to add here in just a second to our notes. Substitution property of equality says if you have something like 2x equals y, x equals 3. Are any of our sides identical? No. But we can substitute 3 for x. So when we take this 3 and we plug it in for just this one little part of the side, that's the substitution property. Does that make sense? Okay, so add to your notes down here. You had combine like terms or simplify. Then you also have another option you can use, and that is substitution property of equality. Oh, it is, sorry. Never mind. It's right here. Okay, substitution property. Any questions about the substitution property? All right. So these are the properties that you are going to use on your algebra proofs. Um, that's it? That's it. Okay, so now we're going to practice. Okay. Solve the equation. Write a justification for each step. When you see write a justification for each step, you're going to think two-column proof. Okay, T-chart, two-column proof. Every time on the homework tonight, because we're going to set these up different than the book. If you look in the book, they're not going to do them as two-column statement reasons, but Lashley's saying you have to do two-column statement reasons to get us prepared for tomorrow. Okay? So you're going to set your T-chart up, statements and reasons. Everybody with me now? All right. Your first statement is almost always going to be given to you, which in this case it is, and that is this equation. So you write down your equation. 4m minus 8 equals negative 12. Be careful that you don't confuse numbering your step with part of the problem. So I usually use like a little parenthesis or something. You can put a point if you want, but just don't confuse that as a decimal, like 1.4, okay?
I put both. I put one.
And then your reason is going to be given. Okay? And again, almost all the time, that'll be your first step. Then you're going to go through. Here's the thing I'm going to be picky about. You don't show your work in a proof. Okay? That's weird, right? You do it in your head. Or if you need to, go over to the side and write it down. But in your proof, you don't show your work. A proof is this is what is given, and the next result I would get is what I write down. So what do you do here to solve? Add 8. So either you're going to do it over to the side, add 8, or you're going to do it in your head. Add 8. You do not write that down in your proof. You write the next step. 4m equals what? Negative 4. So this is one time that I'm telling you not to show your work. Do the math in your head. Okay. So then your reason here is what property? What did we use to get that? Exactly. So you just put addition, property of equality, and you can use the equal sign. It's easy. I told you today won't be bad. We're going to work our way up to the harder things as we go, and that will make it seem easier. It's not that bad. Okay, number 3. What do we do next? Divide. And what I usually do, and it's up to you guys, but for me, when I think that's what I'm doing, I go ahead and write my reason down first. What am I doing to both sides? Dividing. So division, property of equality. Right. So then we divide by 4 in our mind, and our answer for 3 is m equals negative 1. And since our variable's on the left, we do not have to use the symmetric property. You won't, because you have to write down what was given. There's no reason to flip it and then flip it again. You could, but I would probably take off points because you're adding in steps that weren't necessary. Okay? Yes. Yes. Good question. Listen, guys. A proof is supposed to be a logical step to get to your solution. If you throw in things that aren't needed, then that's not part of your proof. You will miss points for having stuff that wasn't needed there. Okay? You don't have to circle your proofs on your homework. The whole thing is your answer, so don't feel like you have to do that. All right, go ahead and try the next one, and then we'll check it. Okay, let's check. So step number 2, you should have listed it, statements, reasons, got this down given. What is your statement for number 2? T equals negative 14. Okay, what is your reason for number 2? Okay, I heard 2 different answers. What did I hear? Multiplication property or division property. Both of those are valid. You could multiply both sides by 2, or you could divide both sides by 1/2. So your reason here has 2 possible solutions, and either one would be acceptable. If you thought multiply by 2, you're going to put multiplication property. If you thought divide by 1/2, you're going to put division property. And you would get credit either way. And there's often proofs can be done not necessarily in the exact same order. There'll be some things that have to be listed before you can make a conclusion, but those things may be able to be listed in different orders. So it's kind of hard to compare your answer with your neighbor's answer all the time because they may be different. It is. Proofs are not the most fun. Yeah, all right. Make it hard on Lashley. That's right. That sounds like my husband. You wouldn't have to grade all that homework if you didn't give it, right? Okay. So next one is when we get into some word problems. These are probably the hardest. It says, again, write a justification for each step. The hardest part of the word problem is you've got to read through and pick out what's given to you and list it, okay? So we're going to do this one together. Start with your T-table, statements and reasons. Number 1, let's read through and find out what they're giving us here. It says, what is the temperature in degrees Fahrenheit, F, when it is 15 degrees Celsius? Stop right there. Did they give us any information that we could write down? Okay, so how would I write that? What are they saying when it comes to this equation? Yeah, 15 equals not 9 over 5c.
F is equal to 9, 5, 15. F equals 9 over 9.
Okay, this is part 2, but skip this for a second. If they're telling me 15 degrees Celsius, what are they giving me that I'm going to write down that eventually I'm going to use in this equation? C equals 15 degrees. If it's 15 degrees Celsius, then they're saying C is equal to 15 degrees. Does that make sense? Okay, read the next part. Solve the equation F equals 9/5 C plus 32. So they're giving us that equation as well, right? So we're going to list that down. F equals 9/5 C plus 32. So they've told us C is 15 degrees. Here is this equation. And then they say, solve the equation for F and justify each step. Do they give us any other information? No. You can list multiple things at the same time if it has the same reason. You don't have to write them as separate steps and write given, given, given. There may be times where you want to separate your given, but you don't have to. So all of this was given. We can write it all in step number 1. No, we don't need a calculator. Okay. Number 2. What would we need to do to solve for F? Substitution property. So number 2's reason is going to be the substitution property of equality. And then we're going to plug in that 15 for C. So we're going to have F equals 9/5 times 15 plus 32. Where you've substituted it in. Does that make sense? Okay. What do we need to do next? We need to simplify. We're going to multiply here, but we're only doing it to one side, so it's not the multiplication property. No, it's just either combine like terms or simplify. That word can be used interchangeably, and it doesn't matter. So we're going to simplify here, and then what are we going to do? We're going to simplify again. We're going to simplify here, Whatever we get, we're then going to add to 32, but it's not the addition property because we're doing it only to one side. So if you want to, you could do that all at once and just write simplify one time, or you can do it in separate steps and write simplify twice. Okay? So number 3, keep in mind that you can easily simplify that without making your numbers bigger. If you have 9/5 times 15, what is 15 over? 1. Don't multiply and make big numbers. Cross cancel. When you're multiplying, you can always cancel out any numerator with any denominator. So 5 goes into itself and into 15 3 times. Make that easier. Then what is 9 times 3? Over 1, which is just 27. So if you want to do it in 2 separate steps, you could do F equals 27 plus 32. Your reason is simplify. And then your last step, number 4, would be F equals what? 59. Make sure good that you include your units, degrees. And the answer again would be simplify or combine like terms. Okay, whichever you want to do. Yes, ma'am. As far as those words go,
Like the symbol for
just the degree symbol that you don't, just degrees. Because Celsius and Fahrenheit are both measured in degrees, so it doesn't matter. You're just using those letters, C and F, as your variables. But that's it.
Like, help me. There is no degree.
Questions here?
Yeah, I've done it in science.
Good. All right. So now we should be getting ready to look at some geometry type problems. Okay? All right. We're gonna baby step in today. Okay? So, reminder of one of the most important things I have mentioned over and over in here. What does this stand for? The length of a segment, not a segment. What's another word for length of a segment? Distance. This represents the length, which is the same thing as distance. This is what? Line segment. Okay, it does not have arrows. It is a line segment. Remember our really picky notation. You can say that distances are equal, or you can say that segments are what? Congruent. And this is going to haunt you throughout all of our proofs if you don't get that mastered right now. Okay? Super important. No line segments when you're using equals, line segments when you're using congruence. Okay? I can't stress it enough because it's going to be used over and over and over, and you'll be so frustrated every time because I'll keep taking off points. Okay. Here is where we're going to use a little bitty bit of geometry and a lot of algebra, okay? So it says write a justification for each step. We're going to make a T-chart. This one's going to be a little bit long. Statements and reasons. This is where it gets harder for you because you are smart students. Because the first thing that you're going to want to do here is start with writing an algebraic equation. But you cannot just start with writing an algebraic equation because that's not what is given to you. Okay? They didn't give you an equation. So you've got to come up with, what have we learned in geometry that says we can write an equation here? Okay, and what is that called? It's a postulate. Segment addition postulate. And this is where it gets hard because you have to know those names, okay? So you have to go back. So listen, I'm going to show you something in your book. It's going to scare you a little bit, but it's also helpful, okay? In the back, in the very back of your book, in this little kind of sea green color, kind of a teal. Yes. Okay, this is where they have listed by chapter all the postulates and theorems. So the nice thing is you don't have to pull out all your notes and flip through all the slides. You can just look right back here if you can't think of the name of it as you're doing your homework to try to practice and study. Okay? The reason it's a little scary is because we've learned all of these for chapter 1, and we're going to learn these in chapter 2, And if you turn the page, it kind of scares you a little bit because they start getting extreme. But what happens is the definitions get less and we learn more postulates and theorems. So your vocab tests get a lot smaller, but then you've got more postulates and theorems you've got to learn. Okay? They're back here in the back, though. Highly recommend you use that. I know, I'm sorry. Okay, so we're good, though, right now, right? Segment, addition, postulate. Here's what I promise you. If it's used on the test for that chapter, we will have talked about it in class, that chapter. So when we get to chapter 6 and we have a proof on the test, there's not going to be some reason in your proof from chapter 1 that we have not recently in chapter 6 talked about and used in our notes or on the homework. Okay? So we will re-review everything you're going to need. Definitely. Okay. All right. So segment, addition, postulate. Now be careful. What Caden said is what you have to start with. The segment addition postulate does not say that variables and numbers add together to equal variables and numbers. It says the distance of the line segment plus the distance of the line segment equals the whole distance. So you won't use the 2x, the 3x minus 9, or the 4x minus 4 yet. Very good. Number 1, you will say, go ahead, Karina. Exactly. That is what your segment addition postulate says. Part plus part equals whole in the picture. And your reason? Segment addition postulate. No line segments. You're using pluses and equals. No line segments. All right? Next thing is we have to list what was given to us in the picture. Most of the time your given will be listed. When we get to geometry proofs, it'll say given and it'll list your given. But right now they're just giving you a picture and you're going to list from the picture what you're given. So number 2, what's something in the picture that we know? Okay, so we're going to say NM is equal to 2x. Does that make sense? Okay. Same reason we can. Exactly. And at the same time, we could also put. Exactly. And the reason for number 2 is given. And so this is the one time, Caden, where we're not putting our given first, but you could have. You could have listed your given first. The order in which these are listed doesn't matter. Would you agree that one did not depend on the other? So the order in these can be switched. If you prefer to write your given and then put your segment addition postulate down, that's totally fine. Okay? These two could be switched. You could have listed the given from the picture first and then said, now I know I need to use the segment addition postulate. So the order is not affected. The only time the order matters is if you need to use something from up above to get to what you're going to say next. You can't switch the order. Okay? So what are we going to do next? I heard somebody say it. I heard that's a good question, but I also heard somebody say, very good, Morgan, substitution. We're going to substitute the 2x in, the 3x minus 9 in, and the 4x minus 4 in, and we can do that all at the same time. Does that make sense? No. So let's look at when we write it down and see if that helps. So instead of putting in m here, what are we going to write? 2x. Then we have the plus sign. Instead of writing mo, what are we going to put? 3x minus 9 equals 4x minus 4, which is where you would want to start in your mind if you were looking at that problem, because we did several of those back in chapter 1, right? But for proofs, you've got to set it up with why do we know we can write that down? Because the segment addition postulate says we can, and we use what was given, and we substituted. So substitution, make sure you can spell substitution. Property of equality. And now this is an algebraic proof from here on down. So just a little bit of geometry at the beginning, right? Not much. Algebra here on down. So let's finish it. Number 4, Okay, I've heard simplify or combine like terms, whichever one you want to write. I'm lazy, so I'm going to do simplify. No abbreviations. All right, so if I combine like terms, what am I going to have next in my next statement? 5x minus 9 equals 4x minus 4. You need to make sure I can read it. If I can't read it, it'll be wrong. So you may have to write a little bigger. You don't have a lot of room on your notes, but you'll have a piece of paper where you can write as big as you want, right? There you go. Just make sure I can read it, Javi. Okay, moving on. Next step. Number 5. What do we want to do? Okay, I heard add 4 to both sides. At this point, it's going to change maybe for some of you. Because some of you may say, I'm going to add 9 to both sides. Some of you may say, I'm going to subtract 4 from both sides. So it can be different orders from here on down. 4x, sorry. Subtract 4x from both sides.
Okay.
So it may be however you want to solve it, your next steps could be a little different. Bless you. All right, so I heard add, what do you want to do?
5.
Add 9. So what is our next statement going to be? Okay, that's our reason. I'm going to go ahead and write that. Our reason is going to be addition, property of equality. What's my statement going to be?
5x equals 4x plus 5.
5x equals 4x plus 5. Because we added 9 to both sides. Don't show your work. Do it in your mind. If you need to show your work, do it separately over to the side. Okay, number 6. What do you want to subtract? 4x. Okay, so I'm going to go ahead over here on my reason and put subtraction property. Sorry, one second. Subtraction property of equality. Question?
So I'll say for number 5, instead of addition, use subtraction. Subtract 4x.
No, because those are 2 separate steps. You're using the same property, but one depends on the other. You can't do that second subtraction until after you've done the first subtraction. It changes your statement completely. So I want you to show every single step.
We're solving for x, we're solving for...
It just, we're solving for x. It didn't say to go through and find NM or MO or anything like that. Okay, so if I subtract 4x, what's my statement? So x equals 5. Is my x on the left?
Yeah.
As long as it is, we do not need that symmetric property. If it's not, you need to flip it over. So you don't need that step. It is implied to be a 1 anytime it's not there. So we don't need to divide away a 1. Say it again. Do not need division property. Mhm. Did that make sense though? Okay. All right, flip it over. What's on the back there? We've got the same kind of idea. We're gonna set this up, but we're not going to work out the algebra part. I think you can handle that on your homework. So to save time, we're just gonna set it up. So starting with statements and reasons. Once we get to the algebra part, we'll stop and move on to the rest of the notes, okay? So first thing you need to do is look at, they want you to write a justification for each step. We're trying to solve for x. Okay, so I'm hearing 2 different things. Edwin's starting with listing what's given, but Alexis is telling me what? The parts. And what are you doing with those parts? You were trying to write an equation. So what geometry concept are you using right now to do that? It's not segment addition postulate because we don't have segments. Angle addition postulate. And it doesn't matter which one, just, yes, it's not hard. See, I told you it's going to be easy.
Hey, I didn't even know that postulate. I just guessed.
So if your picture is a segment, it's segment addition. If your picture is an angle, it would be angle addition. Postulate. Yes. You can put the angle symbol. All right, and so be careful when you write the postulate, though. Remember, it's not with the variables and numbers, it's with the names. And make sure you use correct notation. So what am I actually going to write down here for step number 1? Okay, be careful. You're missing a couple things that need to go in front of those measure. So little m, angle ABD plus measure of angle DBC equals measure of angle ABC. Now, we could have done what Edwin said first. We could have listed our given. So again, it doesn't matter which order those are written down in. Step number 2, we can now list our given. Again, make sure you're using correct angle notation. Measure of angle ABD is equal to what? 3x plus 5. Measure of angle DBC is equal to what? Mm-hmm. 6x minus 16. I'll slow down a little bit. And then our last one, measure of angle ABC is equal to 8x. And that sometimes is missed in the picture, so be really careful because when they write it down here below, you might not see it. Be really careful. So that is equal to 8x. And what's the reason? Given. Okay? And then we're going to do the exact same thing that we just did on the last one. So instead of writing it all down, what is the next step that we would have done? Substitution. We would write our equation. We would substitute each of these in, and then we would just start solving it. Does that make sense? You would have to do it if this were a homework question, but we're not going to do it on the notes since we just did that exact same thing. Is that okay from there? Okay. And would you agree that's just a little bit of geometry, mainly algebra? All right. So last things we're going to talk about are those 3 properties that I told you were so important for geometry. Reflexive, symmetric, and transitive. What I didn't tell you is there's kind of a little trick you can use as you're first learning them. Reflexive starts with an R, symmetric starts with an S, transitive starts with a T. And that's in alphabetical order, R, S, T. Reflexive is one equation, A equals A, 5 equals 5. Symmetric has 2 equations. If A equals B, then B equals A. Transitive has 3 equations. 1, 2, 3. A equals B and B equals C, then A equals C. So, if you get stuck, and what we're getting ready to do is look at a few examples that will be on your homework that are not proofs. So your homework is not entirely proofs. But it's a little trick that might help you get those kinds of questions right. RST 1, 2, 3, if you're thinking, how many equations do I have, okay? So, last thing you see here in your notes before we do our last examples is the same 3 properties, but what's changed on them? Reflexive property of congruence. So now they're changing this from equality to congruence. And again, if you would like, you can just put that little congruent symbol. Yes, you can use that congruent symbol if you prefer. Okay? And here's what it says, and this is where we get into the geometry, reasons for these. Reflexive property in geometry would say a line segment is congruent to itself. And where you're going to see that tomorrow is when you have something like this. And you might be trying to prove eventually that this triangle, ABC, triangle number 1, is congruent to this triangle, triangle number 2. And to do that, you might need to show that this side BC is congruent to itself because they share that side. So to do that, you would need to say in your proof, BC is congruent to BC to prove that it's congruent to itself. And you would write that, and this would be your reason. Okay? Reflexive. So reflexive property says something's congruent to itself. So when 2 objects share a common side, you may need to try to say in your proof that that side is the same length as the side in the other triangle. So BC in this left triangle is congruent to BC in this right triangle. And yes, there's going to be proofs we'll do that you have to do that in. And when you do it, the reason that they're congruent to itself is reflexive property of congruence. Okay? Another situation where you might see it is in something like this. You might need to look at that as two separate triangles. Do you see a little triangle here, ABE? And then do you see the big triangle, ACD? The big one here, ACD? Okay. And do you notice that they both have the same angle A in them? So you might need to say angle A is congruent to angle A. And if you do, that's the reflexive property of congruence. We're going to learn it when we get more to the geometry problems. So right now, you're not doing geometry proofs tonight. You're doing algebraic proofs with only maybe segment addition postulate or angle addition postulate, okay? I'm trying to set this up for where we're headed tomorrow. So if you learn that you need to do that tomorrow, the reason you can say something's congruent to itself is reflexive property, okay? Don't use it hardly at all if you're doing an algebraic proof. All right, symmetric property is still the same. It's going to flip it. So if you have angle 1 is congruent to angle 2, then you can flip it over and say angle 2 is congruent to angle 1. That's symmetric property. It's just of congruence. Notice what's in your statement should match what's in your reason. So if you have a congruent symbol in your statement, it should be a congruent symbol in your reason. Okay? Transitive property, same thing. Three statements. If PQ is congruent to RS and RS is congruent to TU, so notice they've got the same thing in them. The whole side's exactly the same. We just get rid of the part they have in common and say that PQ is now congruent to TU. That's transitive, not substitution. First of all, substitution property is only of equality. Only of equality. There's not a substitution property of congruence. So it has to be an equal statement before you can substitute. And substitution property is when you don't have the same thing on one side. Okay, but you're substituting something in for a piece of one side. Does that make sense? Okay, so look at the last examples. I've already said that a million times, so I'm not going to repeat it. Okay, we'll do these together, and then you'll do the next four by yourself. Identify the property that justifies each statement. This is not a proof. It just says identify the property. Even though it says that justifies each statement, it's still just asking you to identify just the property. Okay? So part A, what is this the property of? Reflexive property of congruence. Notice the congruent symbol. So you would write reflexive, property of congruence. Everybody with me there? And again, think RST, 1, 2, 3. That's going to help you so much on these kinds of questions. There you go, yeah. All right, part B. If measure of angle 1 is equal to measure of angle 2, measure of angle 2 equals measure of angle 1. What is that? Not transitive. It's got two equations, and we're flipping it, right? So it's symmetric property of what? Equality this time because we have an equal sign. Two M's. Symmetric property of equality. And again, I want you to understand what it does, though. Don't just think 1, 2, 3, RST. You need to think, what does the symmetric property do? It flips it, okay? Part C. This is going to be transitive. We got AB is congruent to CD. CD is congruent to EF. They have the same part CD. So we end up with AB is congruent to EF. There is 3 equations there, though, so that helps. So we have transitive property of what? Of congruency. And then the last one, what do you see there? Very good. Reflexive property of equality this time. Make sure that what's in your statement matches what's in your reason. All right, do the last 4 and then we'll check them. Yes, ma'am. because we are going to practice for the end of course test, and you're going to make sure that you are explaining well to people from the state who do not know you, do not know what we have learned or how I've presented something to you. And so, yes, when we have to take our end of course test this year, our ACT Aspire, we want to make sure that we're doing a really good job of explaining. So if you get a good habit of that now and don't abbreviate, you'll be ready to do it then. All right? All right. So do the last 4. Let's check it. And then you'll have about 25 minutes or 20 minutes to work on the homework. That's not true. We're going to do one of our problems together. But it's on the homework. So it really is on our homework. I don't know why I count this every time. I'm pretty sure I have the same number, but I don't know now. I feel like I don't. That's only 4. Do I have an extra one? Yeah. Because see, I can't count. I'm a math teacher. I can't count. I don't know. When you get these finished, you're going to need your core math book. So if you'll get it out. Are we ready to check these 4 yet? Give me just a minute. Helps, right? RST, 1, 2, 3. Now resume. RST, 1, 2, 3. Okay, let's check them real quick. 4A, what do you see? Symmetric property of? Equality, good. B, what do you see? No abbreviations, I know, but no abbreviations. Reflexive of equality. C, transitive of equality. And D, you guys got it. Be careful, 2 M's on symmetric. It's reflex with an X. Be very careful, okay? Spelling. I know, do not abbreviate, okay? Don't abbreviate, Tyler, but they did. I just showed their answers instead of writing it myself, okay? All right, core math books, homework time. We need to fix a mistake, and then we need to do one problem together off your homework. Bree? Did I not hole punch the notes? I haven't for a while. Okay, I'm so sorry. There are hole punchers at the back, but I have been hand hole punching them for you ahead of time in chapter 1, and then I must have forgot when I did your chapter 2 notes. I'm so sorry. Our copier, they have not installed the hole puncher on it. I don't know if they're going to, because the guy said that the bid they got this year from our central office didn't include a hole puncher. Come on, we can afford a hole puncher. But anyway, so I apologize for that. But there's a hole puncher back there if you want to hole punch them. Yeah, I did them all at the same time, so I probably forgot. I'm so sorry. I'll do better. But they're not going to be better for the next couple because they're already done. So sorry. Okay, here we go, quickly. We want to fix a mistake. So on number 4, on core math page 73. So get core math page 73. Go to number 4. If you rip it, you can tape it. Number 4. They left off a step. And on all of these, I want you to remember, you're adding A T-chart.
Oh, yeah.
Statements and reasons. Okay? So we're going to add statements, reasons. Yep, that's not statements. Sorry, thank you. Statements. That's still not spelled right. That's statements. That's right. Statements. All right. And reasons. But here's the thing. They left off a step. So if you're numbering these, 1, 2, 3, 4, 5, 6, they actually left off one, so we're going to add in a step, okay? So I want you to put number 1 up here, that's blank, or if you don't have room, draw an arrow and write number 1 down here. But somewhere put number 1, it's going to be an extra step we're going to add in. So either make it fit up here at the top, or draw an arrow that goes down here and put 1 down here if you need to. I can handle it either way. Whatever works for you. But they missed the step. When you look at all of their statements for this problem, what step do you notice they did not list? Say it again, Molly. The given. They didn't list the given. Okay? So step number 1 needs to be your given. What's given in the picture? HI equals 2x plus 6. IJ equals 3x minus 3, and what else? HJ equals 7x minus 3. Cram that in up there somewhere and write the reason is given. Then number their steps 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. So, one mistake there, one just to fix. This book, to be honest, has lots of mistakes in their proofs. So if you look at their answers in the back of the book, it could be that you have yours perfect and theirs is wrong. They made this book really fast when core math came out and we had all these new frameworks, and they tried to rush this textbook and there was a lot of mistakes on the proofs. So, excuse me? One more time, I didn't. Yeah, maybe. I'm sure they fixed it by now, but we have the old version. So, there you go. All right, we're going to do a different problem together, though, okay? So flip over on the back. Let's do one of them together. How about that? Okay? So we'll do number 1 together. So we're going to set this up, just trying to help you one more time with those word problems, okay? Are we ready? So, solve the equation for P, justify each step. That means we're going to write a proof. Make your T-chart, statements, reasons. And we are going to start listing everything from the word problem that they give us as our given. So statement number 1, read your sentences. Because of a recent computer glitch, an airline mistakenly sold tickets for round-trip flights at a discounted price. The equation, blah, 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 relates the number of discounted tickets sold in the price of each ticket, P, and the tax per ticket, T. So what can we list as our given? What are we going to need if we're going to try to solve for P? What did they give us there that might help us solve for P? Okay, we haven't read that part yet. What part did they give us in the second sentence? The equation. In parentheses, P plus T. Oops. P plus T.
Why is there a T in here?
P plus T, make it have a little curve. P plus T equals 3,298.75. And the reason is given. Okay, let's see if there's anything else. It goes on and tells us what each of those letters are for, so keep that in mind. N is the number of discounted tickets sold. P is the price of each ticket. T is the tax per ticket. What was the discounted price of each ticket? So what stands for the discounted price? N is the discounted, oh no, N's the number of tickets. What's the price? P. P is the price of each ticket. So we're going to try to solve for what variable? P, because it says what is the discounted price? If 1,015 tickets were sold and the tax per ticket was $1.39.
So would it equal,
Go ahead, Edwin.
would it equal 1,000?
So 1,015 tickets, and what letter stood for the number of tickets? N. Number of discounted tickets sold was N. So we would write what down here? N equals 1,015. What else did they just give us there? The tax. What letter was tax? T. So we could say T equals $1.39. And all of that was given, right? Okay, so what are we going to do to solve for P? Substitution. So step number 2 for the reason is substitution property of equality. Then let's substitute it in. So now we have 1,015 going in for N. P is what we're solving for. Plus $1.39 goes in for T equals 3,298.75. Okay? From here, what do we need to do? Distribute. So go ahead on number 3 for the reason. Let's put distributive property before we forget. Distributive property of equality. And now we're going to distribute. And do you think that this is the kind of question you should do by hand or with a calculator? With a calculator. You can definitely use a calculator for this. We don't need it right at first. This is 1,015 P. Hopefully we knew that. Plus, and then does anybody have a calculator handy?
Yes.
Go for it. All right. So Ridley's going to tell us what is 1,015 times $1.39.
Is that IVE?
1,410.85.
Oh,
I'm sorry, say it again.
1,410.85.
Okay, so 1,410.85 equals this 3,298.75. Everybody okay so far? So what step do we want to do next? Good, subtraction property. So I'm going to go ahead over here on my reasons and put subtraction property of equality. And then Ridley's going to help us out and take that 3,298.75 and subtract the 1,410.85. And we will have written down 1,015 P equals whatever Ridley gets. Don't mess up, Ridley.
Questions on? Double check.
1,887.9. Okay? What's our next step? Division. I'm running out of room here, so I'm going to make another little chart over here and put step number 5. Step number 5, division property of equality. P is going to help, or yeah, Ridley's going to help us out figure out what is P. P is equal to what? Very good. Make sure and put your dollar symbol there, going back to your units. It is $1.86. Now, That is quite the error if you can get a round trip ticket for $1.86. Yeah. It's crazy.
Now back to 92.
All right, that is algebraic proofs. You've got your homework. You've got about 10 minutes. See what else you can get accomplished there on the worksheet. Keep in mind, you're only doing proofs if it says write a justification for each step. So for example, 3 and 4 are multiple choice. You're not writing a proof, okay? Just if it says to.
You could use the your addition possible.
Oh, this is Thursday, so this is due when? No, because we don't have school. Tuesday. Okay. All right. Even better. I know. You do have practice at 1 o'clock?